Also, we can find these assistants as physical companions, like the one in this picture. This actually existed. It was called Jibo, but it was discontinued. And we can wonder also if we do really want this kind of devices, because we can see they are very happily. The humans are playing outside and he is like inside with the robot, but maybe he cannot move and do things like that. So maybe it's not a choice he can do, and it can help him a lot. Also, we can use AI to write essays, like, for example, this one that was written 2 years ago by GPT-3, which sounded quite outstanding. For example, it says, "I'm not human, I'm a robot, a thinking robot," etc. I'm not going to read it because of time. However, you can see that it seems to have kind of self-consciousness of what it is. It knows it's a robot, apparently. However, what it was said later is that this nice essay was asked to be written like that, and at the end they also had several different outputs or essays, and they mixed the best parts of each. So although it sounded like very self-awareness, at the end it was picked up. 2 years later, now we have ChatGPT. I'm sure you have heard about it. It was launched at the end of November the 30th. And it shows, it was just the first time I asked to generate this, and it shows a not so light view on AI. For example, it says, automatic text generation tools have the potential to manipulate and control public opinion. It is possible to create the illusion of widespread support or opposition to a particular idea. So it seems it's not quite optimistic regarding these kind of tools. However, it is important to say that the prompt was focused on why humans have to fear AI. So of course, it's saying that it could potentially lead to widespread confusion and chaos. So it's very interesting how we can actually use these kind of things to make it happen. So it's like a self-referencing thing. We are asking it to focus on this thing, and of course it says it can happen. So we must be cautious when we are reading this kind of ChatGPT generation on what was the prompt it was actually asked. So we can also create machines to be like us, that since centuries, I'd say it has been tried, even from Greeks that had this Pygmalion story, that it was a sculpture that was so, it fell in love so hardly with his creation that he wanted to be alive. And well, at the end, the gods helped him to achieve this. And finally, we have our creation that we are having to give us further ideas. So I like this drawing very much. It's by Tony Veal from the UCD, because it depicts what I want to talk about today, that we can create something, but this something can also give us insight about ourselves, about how we are thinking, about what do we want of our creations, what do we want, where do we want to go. So this adventure of creating new things is not new. Since the origin of the word robot in 1920s, which comes from a novel by Karol Čapek, we have had these kind of elements. We had this 1928, this robot called Eric amazed people by showing its movements, which was very simple, just sitting and standing up. And however, they had already these kind of analogies by saying it has a pump for a heart and things like this, representing some lungs and trying to mimic the organs of a real human. So finally, we arrived to this goal, that is to better understand ourselves. So this began also many years ago. We can trace back to 1966 to Eliza. We have Weissenbaum here writing in a teletype, which is an interaction with a machine that did not have CRT, a monitor. How it was like a more typing machine. And the kind of conversation it was possible to have with Eliza was like this: men are all alike. In what way? The uppercase letters are by Eliza. They are always bugging us about something or other. Can you think of a specific example? Well, my boyfriend made me come here. Your boyfriend made you come here. He says I'm depressed much of the time. Oh, I'm sorry to hear you are depressed. It's true, I'm unhappy. Do you think coming here will help you not to be unhappy? I need some help. That much seems certain. What would it mean to you if you got some help? Perhaps I could learn to get along with my mother. Ah, tell me more about your family. So it seems like a very understanding dialogue here. However, it's made of very simple strategies. For example, if we say something are all alike, X are all alike, we can always ask, in what way? So you can say, all phones are all alike. In what way? So this answer will always trigger conversation in a proper way. Or we can say, always it triggers proper conversation in a proper way, or always rain comes after a lot of clouds. Can you think of an specific example? So we can see that we are having actually this conversation trick working. We can also try with other people, or when we are learning a different language. Or I need something. What would it mean to you if you got something? I need a new car. What would it mean to you if you got a new car? So it will always work, or most of the times it will work at a certain point. Or if we are talking about some keywords like mother, well, tell me more about your family. We have also some other keywords like depressed or unhappy that trigger some predefined answers. So what was Weizenbaum trying to do here was twofold. First, wanted to see if by having minimal context, it was possible to recreate communication. And second, by that time, other machine talking software like Student or it was not focused on talking, but solving specific equations and things like that, or trains, or other elements by that time, people were starting to think that we were able to talk with the machine easily in the future. So what we tried to do is to show with this paper how could he apply Eliza to this kind of conversation. So Weizenbaum regarded Eliza as a sort of translator. And people started to feel that they were actually talking with someone who could understand them. And this is the interesting part also I want to highlight here, because he wanted to answer or to seek the answer if humans and machines could understand each other. And of course, this is very similar to the famous question of Alan Turing of can machines think, which at the end he says, well, we don't know if they can really think, but how can we be sure that, or we can approximate they are thinking? Well, by the output, which was the Turing test was based on the imitation game. So Turing publishes his these ideas in the Mind journal in 1950. And what is known as the famous Turing test, it's stated in just this highlighted part. He said, I believe that in about 50 years' time, it should be the 2000 year, it would be possible to program computers with a storage capacity of about 10 to the power of 9, it doesn't say what, to make them play the imitation game so well that an average interrogator will not have more than 70% chance of making the right identification after 5 minutes of questioning. And that's all. So it's surprising how something which is so often referred as a formal test, like the Turing test, it's so quickly defined. And it leaves a lot of questions. For example, what kind of questions? 70% of making the right identification, maybe mistaking it by a real human, but it says also an average interrogator. What's an average interrogator? A kid, an adult, someone which is doing a PhD on NLP, for example. So there are a lot of questions that are undefined, and not because he was able to do that, but because he didn't want to stress too much or to focus too much in this part. So the famous Turing test test is not the focus of this paper. However, this paper caused lots of confusion since the 1950s, because from here, a lot of efforts were devoted just to pass the famous Turing test, which at the end it was to measure the ability to fool people, distracting from real applications that these conversational agents could have. So we were trying just to talk like a human, but we didn't focus on the applications of being able to talk like a human. So why this works? Well, because I wouldn't say just that people are easily fooled, but because we are trying to find meaning on the other side. For example, if we read something with chaos, which is not well written, we try to find the meaning behind that. Even when we have nonsense, which we can find, for example, if you have read the Burroughs works, we can see there is a lot of nonsense. However, we are trying to find some ideas there. Or we are trying also to see shapes, known shapes, for example, in clouds, that we can see the sky and say, oh, well, they are dragons, because we want to believe, we want to find meaning. Or even the famous test of the Rorschach blots, which is like the one that is on the back. And we can try to find some figures, maybe people escaping, or maybe two persons here dancing, something like that, because we want to find meaning. How much different is interpreting non sequitur, which is what is not explicitly said, as whimsical conversation, meaning a shift on conversation? Well, maybe he's just trying to change conversation. Let's try to adapt. Because when we are talking, we are very willing to adapt to understand what the other is saying. So that's why this behavior, it helps us to try to talk with others. So have things changed that much? Well, in one sense, it seems not that much, because we have the same robot I presented to you a few moments ago, people being amazed at it. And then we have just a robot that is also behaving the way it's programmed, but some people even have given her the citizenship, right? Because it seems to be a really independent being on its own. However, it is not. And well, maybe sorry for saying it, but I think it's still a robot. So going back to the therapy applications, what happens with ELISA? What kind of therapy it could deliver? Well, mostly it was based on the theories of Carl Rogers, which is called Rogerian therapy, which makes an essential assumption, which says that the participants, one of the participants, usually the therapist, is free to assume the pose of knowing almost nothing of the real world, which works very well for a machine. So when the patient says, I went for a long boat ride, the therapist can ask, tell me about boats. Not because he doesn't, or he or she doesn't know about boats really, but because in the description on what is salient for the patient about boats will tell him more about how the patient can see the world. So in those times, they also modeled a patient called Perry, which was a paranoid patient. And they have interesting conversations that were shown in this paper as well. And the interaction is shown here, like, tell me your problems. People get on my nerves sometimes. I'm not sure I understand you fully. You should pay more attention. And well, this is fun to read. I won't read it today because of time. However, you can find this talk on the internet. It's 1973. So Parry was put through the ringer, so it means it was tested in the early 70s by a group of 33 actual human psychologists using a variation of the Turing test. So it's supposed to have passed the famous Turing tests, it was said. However, what happens if we, for example, say that foreign boy whose command of English is low? And let me refer to a relatively recent, or at least much more recent than Parry, that was said that he passed the Turing test. This was also famous news article that said that Eugene Guzman was able to pass the Turing test. However, he was like an Ukrainian boy. He hasn't good command of English, so uh, people were very permissive, or were not looking him to have the exact grammar as it should be in English. So, to which extent can we understand ourselves? How much can these therapeutic assistants or uh, conversational agents help us to discover more about ourselves? Well, going back to Eliza, we can see Eliza as a mirror because it seemed to listen for self examination, self expression, self narrativization. And the secretary of Weissenbaum enjoyed talking with Eliza. And when she was talking with it, she said, "Please, everyone in the room, please leave because I'm going to talk with Eliza." So she was really feeling that there was something that could listen to her, or at least to give her back some interesting insight. At the end, I think this is one of the things we can expect or we can try to build with this kind of conversational agents. Perhaps Weissenbaum was not trying to focus on the psychological part, but a bit a work that is less known by Kenneth Colby and colleagues. He really wanted to write a computer program which could conduct psychotherapeutic dialogue, which I think is a very adventurous goal, because does it mean to really have a good therapy? How does it mean to really understand another human being? Can something that is not a human being really understand a human being? And uh, recently, a lot of therapy chatbots have arisen. For example, Wobot is a chatbot that uses cognitive behavioral therapy and uses something which is a bit less known, dialectical behavior therapy, and even mindfulness meditation to help people feel better. It was measured by some experiments, and it showed that people would report that they actually feel better when using this chatbot. And also, there is another one called Replica, which day by day asks its users to write how are they feeling. It has a bit of NLP to see how is the mood. Uh, Basically sentiment analysis to see if more or less positive or negative emotions are changing over time, using mostly lexicons like Luke, which tag a word as a positive or negative. So it was kind of very simple technology regarding NLP. However, it was also reported to be sort of useful for the people using it. Uh, and of course, I want to end this with the Chat GPT, which we can wonder can be used as a therapist. Well, it's difficult to make it enter the mode of therapist because uh, many times it says, "No, I'm not a therapist. I'm not able to give to help you." Why? Because this is a delicate issue. If it takes the role of a therapist, then it's easily to have it mistaken by real advice. And if we have sometimes a real issue or a big problem, well, it's a delicate situation. So when after several trying, several attempts, it's possible to have some answer to, I have many strange thoughts in my head, and it says, well, you can ask these and these questions. And it says like a supposed way. I would use my knowledge as a therapist when I have more information, and to share their thoughts and feelings openly and honestly, and try to seek professional help. So it was always like getting back, like, I am not completely a therapist, but I can give you some advice. And it's even able to generate some dialogues between a psychiatrist and a patient, like always. In this case, it was asked to be a negative psychiatrist. So at the end, it says, "Look, I'm not a miracle worker. If you're really struggling, maybe you should talk to someone else. I'm sure there are a lot of doctors out there who can help you. Good luck." But again, it was the prompt. If you ask him to be rude, ask it to be rude, it will be rude. And then the last example, which is like very charming, very sweet, like, oh, my dear child, you're not a burden. You're a precious human being just like anyone else. So we can see also that these new tools that are arising, such as ChatGPT, are able to have different moods just as humans. And also we can think about, well, if you come to a therapist, which is like maybe like Dr. House mood, like very angry, he will try to share this mood with you, right? And if you go with a therapist with this very sweet, well, he or she will share this mood also with you. So at the end, it's mimicking as we do as therapists. So it is interesting that finally you can do this, and you can select the mood you need to have, but at the end, what is the best mood in order to solve certain issues? So as final reflections, I'd like to end with the thought that there are several approaches to human therapy. As you saw, there is cognitive-based therapy, psychoanalysis, etc. There are many different ways to approach therapy, but we still need to assess its efficacy depending on who will receive this therapy, what are the disorders the people are having, and also the question of what makes a good therapist, which was I talking about the last slide. And is it possible to capture this human activity to help more people? Meaning that, can we have a machine that is able to make people feel better? And at the end, is it desirable? Or maybe we should stick with talking to each other. So I'd like to leave these final reflections here, and thank you very much for your attention.
Thank you, Hiram. I just posted in the chat to everyone if you have any questions. Hiram, actually, if you can stay close by, because we can still open the floor to questions. That would be ideal. If you can come back towards the podium. If anyone would like to ask any questions, you can either post them in the chat. Actually, that would probably be the best option. If you can please post your questions in the chat, and then we can read them off and have Hiram answer for you. So Hiram, maybe I'll just start with a quick question also. Have you looked into any of the concerns about these emotional chatbots maybe giving wrong therapeutic advice? And what do you think companies are doing to help prevent that currently, if that's something that you have looked into?
Yes, thank you. Thank you for this interesting question. Yes, companies are dealing with this. Maybe you remember it was not for therapy, but it was a chatbot created by Microsoft. It was Day, and it started just saying awful things and racism, full of racism, and at the end they have to shut it down a few days after it was released because it was more negative than positive. So I wonder if this kind of technology, for example, reaches a therapist and it starts saying awful things to you, more even more rude than saying go with someone else, well, maybe even mocking or even taking some facts told by the patient against him or her. So yes, it is possible. In this case, by the examples I have shown, they have strict policies. Even ChatGPT, which is not aimed for therapy, however, it tries to avoid as much as it can to say things that can be controversial, like, for example, political issues or opinions, or even if you ask it to say some negative comment about race or ethnicity, it will just say, no, I cannot do that, and it won't let you go past that. So I think that with good policies, it is possible to avoid these kind of things. However, what worries me the most is the how to conduct this session. ELISA is for me not so potentially harmful because the rules that it uses are very understandable. Of course, at the end, you realize it's not a real human because it starts asking the same questions over and over. However, when you have a more complex model, we have the problem that something by going through the back door can arise.
Thank you very much. And we have another question. With large NLP models writing what seems authoritative scientific papers, what do you think are the strategies that the scientific community needs to take to avoid being overloaded with fake science?
Well, that's an interesting question. I think that when there are a lot of papers which are doubtful, well, maybe the source helps. Unfortunately, and this is a big issue, we have a lot of papers published in arXiv, which doesn't mean that arXiv is not good, but they are not peer reviewed. Even for some journals, the review process is not so strong. So maybe we should be able to have hands-on. For example, we can read a lot of things about ChatGPT, and some people can say, well, yes, it's wonderful, it's a miracle, it's like a miracle. However, if you put hands-on and you can try these things by yourself, you can help to have a better idea of what it's saying. So these are some strategies, and of course, I think replicability is a very important issue. So I think we can trust much better papers that let you try the code, that they let you use their libraries or their software, because in terms of replicability, it's much more trustable.
Thank you. And we have another question here. Maybe we'll end on this one. A similar question, but when do you think sentience and reasoning can be modeled by language models? My understanding is that language models ultimately are predicting the next token in their output sequence, probabilistically, so it's not really sentience, but rather encodes training data and does not truly understand like us humans do. So the real question is, when do you think that this can be modeled by language models?
Well, as I tried to say, but maybe I didn't go deep enough in this when I was talking about behavior, because what we are modeling is only the surface, the behavior. So at the end, we get fooled by seeing this surface and thinking that behind there is a lot of things happening. We assume the other people or the machine, we assume the machine is kind of thinking, because when we see this surface, it seems to be or to realize the surface in a very similar way than when we talk with another person. So I think that I coincide with Eric that they are not really understanding the way we do. Why? Because understanding implies to feel it, or but to feel the world. There are a lot of theories that say that our understanding starts from the mnemic sensorial input. So we start associating things like this is good because it gives me pleasure. So afterwards, we have a symbol for this and we have a word for this, but it goes afterwards. So when we work with language models, we are taking things backwards. We start from the realization of the sentence, and then we try to think it will represent this thing. So I think they will never capture the same, because if we want to really to understand the way we see the world, we should need organic things living and wandering all around, which we don't have. However, the point of this talk was more oriented to, or well, I tried to make it more oriented to, despite this problem of not being really able to understand, they give us a way for talking to understand ourselves a little bit more, to see, okay, now that we are modeling only the surface, we realize that there are a lot of processes running, I would say, in the background for us humans that do not correspond with the processes running with a language model.
Wonderful. Thank you very much, Hiram. That was really great. If everyone can give Hiram a round of applause from your living rooms, we really appreciate it, or your offices, wherever you happen to be today. And then we will now open the floor to our next speaker. If we can have our chair who is announcing our next speaker, please come to the podium.
Yes, thank you. I am Delia Irazú Hernández Farias. I'm a researcher in the Laboratory of Technology Language in the National Institute of Astrophysics, Optics, and Electronics in Puebla, Mexico. I'm the research center where I'm working now is in the center of Mexico, very near to Mexico City. This is a picture of our library, and it is in a downtown, very small, that is called Santa Maria Tonantzintla. So we are near to the volcano. We have a wonderful view of this mountain. So I'm going to start with my presentation that is called Identifying Mental Health Disorders by Means of the Textual Attraction Forces. So it is following a little bit the last talk from Iran that he was talking about these chatbots that try to help the therapist in order to provide some kind of mental health support. In this case, the work I will present you is more in the sense of how we can to identify people having a mental health disorder, not to trying to help them in automatic way, but with the aim to identify these disorders from the content that the users generate in social media. So this is the outline of the presentation. I will start with a brief introduction, then I will speak about method that we working on for detecting mental health disorders. Then I will tell you about our experimental settings, and finally our conclusions. So let's start speaking about the way that we are communicate from last years to now in social media help us to share a lot of ideas, worries, personal concerns, and even very personal situation like mental health. This is because social media offer a face-saving platform to do this. Many times when we want to talk with someone, maybe we cannot say the same things if we have the person in front of us, and it's easier to do in a platform like social media. So these platforms allows to communicate many ideas that maybe it will be more hard to do in person communication. So in these platforms, people tend to express themselves more freely than in other circumstances. For example, taking the example of these chatbots for speaking like with a therapist, maybe it's easier for us, or can be easy for us to communicate some ideas or maybe some thoughts with a chatbot instead of with a people, because maybe we can feel that we are not judged by the other person, so we can express more freely in these platforms. Then the content generated in these social media platforms provide a priceless chance for research purposes. So identifying mental health issues in social media is a very challenging problem for the computational linguistic perspective, because this content is plenty of a lot of misspellings, a lot of content that maybe is not so trust that we can trust in this content, because maybe people is just copying and paste some news or an article or whatever. So it is not easy to capture this kind of mental health issues from this content in social media. But at the same time, this content can be used by professionals in order to identify users that are at risk of having a mental health issue. Nowadays, in natural language processing, there are a lot of papers that are working on mental health detection. Among the mental illnesses that are the goal of this research are depression, anorexia, self-harm, suicide risk, anxiety, post-traumatic stress, schizophrenia, among others. So the community is very interested into help by developing methods for capturing these problems from social media in particular. But not only social media content are used for trying to identify mental health with the help of natural language processing. Instead, we can also work with clinical notes. Maybe the professionals, the health professionals, are taking notes during a session with the patients, so we can take these clinical notes and analyze them and to find something that can be helpful for the professionals. Another data source that is used is the interviews. Maybe we can put this kind of more similar to a chatbot, but instead of a chatbot, maybe it's an interview, and then the therapist is questioning to the patient, and during this session, the interviews are recording, and then we can analyze these recordings not only from the textual perspective, but also for the paralinguistic cues that the people make, their movements, their facial expressions, the sound, the differences in the voice tone, etc. Another source that is used is the narrative text. In some therapies, the professionals ask to the patients to write maybe about something, and then according to this content that the patients write, the professionals analyze them and then find figure out something that can be make some insights in order to help the patient. So and the final data source that I have in this slide is the social media content. That is the content that we are working on. And among this social media content that has been used for research purpose from the natural language processing area, we found data from Reddit, from Twitter, from Instagram, etc. Indeed, there are other social media platforms that are more locally in some countries. So there are some research in particular language, like, for example, Chinese, where they use another kind of social media platforms that is particular in that country. As features for addressing this task of mental health dictation, we identified that many of these works are using textual-based features like back of words, post-tagging labels, engrams, etc. So the most of these works made on social media are analyzing the text generated by the users by considering the content or the kind of words they are using. Another perspective is the use of some lexical resources, like this LIWC was mentioned before by the Dr. Hiram, because it is a widely used lexical resource that contains a set of psycholinguistic categories that can be associated with these mental illnesses. So it is also very often used in order to capture some problems related to mental health. Another perspective is to use affective information. In this sense, the presence of this kind of information about emotion and sentiments are very relevant in order to capture these mental illnesses. As I will take again an example from the previous presentation, where Dr. Hiram showed us how while the people is talking with Eliza, is speaking about I feel depressed, and then start to use this emotion or these sentimental words. So this kind of content is also very relevant in order to identify if a person could have a mental health issue. Indeed, this kind of feature related to affect are very, very relevant for this task. And finally, another kind of features that are being used are context-based. In this sense, is like the user profile information. In some works, the authors consider, for example, the time when a given post is published. For example, it may be people having depression tend to post in the late night, or maybe they are following certain profiles or something like that. These are the other kind of features that have been used. As a classification schema, mainly we found recently the use of deep learning methods like word embeddings, convolutional neural networks, recurrent neural networks, transformers, etc. But also there are some papers using more traditional methods like super vector machine or decision tree that have shown also very good results. One thing that all these literature have in common is that all these approaches address the mental health detection task as a binary classification problem. So this is important because in our case, we decide to consider or to take a particular attention in some of the drawbacks that these approaches, considering a binary classification schema, could have. For example, in many of the data, we found a data skew distribution towards the negative class because it's not an easy task to develop a data set for working with mental health. We also identified that there is a weak coverage of the negative class in the sense that if we are trying to classify people having a given mental health disorder against those that does not have this mental health problem, it is not easy to characterize all these people that is healthy. So, and the other thing that we identify is that maybe we cannot have a full certainty of the annotations because sometimes maybe some people, even having a mental health disorder, they are not expressing this situation in social media, so we can just not consider this in order to develop our data, and then we could have some false negatives. So we decide to address the mental health detection task as a one-class classification, paying particular attention to the target class. It means that we are focusing on considering those instances from the positive class. In this case, those people having a mental health illness. So our intuition is that even having only positive examples, we can characterize users who are suffering for a given mental health disorder. We also consider that not all users will have an equally or will be equally relevant in order to construct a classification model. We have the intuition that the most relevant training users will have a greater influence on the classification for unlabeled users. So having this in mind, that even being positive samples, maybe not all the positive samples will have the same relevance for the task in hand, we decide to exploit an algorithm called the Guy Stronger Strengths that was proposed in the paper that I put here, the reference. So this particular algorithm is based on the K-nearest neighbor algorithm that is well known from the machine learning community. But the difference in this case is that instead of considering the distance between the objects in order to decide if a given instance belongs to a particular class, this algorithm is inspired by the Newton's law of universal gravitation. So in this case, in order to consider which are the most instances that are having an influence in my final decisions, we consider the attraction force between the objects. In this sense, we consider that the attraction force between two instances is directly proportional to the product of their masses or relevance and inversely proportional to the square of their distance. So in this slide, you can see that if we have this set of instances and we are interested in to classify this one, the light grid one, if we take the KNN algorithm, we can fix like a K equal to 3, and then we consider these 3 elements and that are the nearest to the instance that we are interested in to classify. And then we decide, like a majority voting, how to determine which is the class of this point. Instead, if we are using the KSS algorithm, we are considering, or we can see that not all the instances will have the same relevance, while in this case, all the instances are of the same size, or we identified that all are equal. In this case, each instance has its own mass or its own relevance. This mass is determined by some criteria that we can define. I will speak more about this later. So we can see that if we are interested in to classify the same light gray instance, we have 3, for example, 3 instances that are those near, that are the nearest to this instance, but not all have the same relevance. So we are not making our decision because the instances are near. Instead, we are taking the decision because the greater the strength, it is the most influence that this will be have in the final decision. So in this case, for making this decision on the mental health problems from a one class classification perspective, we propose the global strength classifier that is following the same idea that from the previous slide, but instead here we are considering that we have a lot of positive instances that are the squares, and we have an instance that we want to classify. So we are considering 2 different metrics. In one side, we are considering which is the target strength. It means the average strength that each of the instance has with the instance that we are trying to classify. And also, we want to consider a reference global strength that in this case is the average strength with which all the instances in the training set are attracted themselves. So here we don't have any instance to classify, but we have all the training data, and like all this training data belongs to the positive class. We take this metric in order to determine if an instance belongs to the target class. So we consider a ratio between the target strength and the reference strength. I mean, how all the positive instances are attracted to each other, and also how the instance that I want to classify is attracted to each of the positive instance in the training set. So if this ratio is greater than a beta value, a parameter that we can determine, we label this instance as positive, otherwise as negative. So in order to apply our GSC classifier for mental health detection task, we decide to define a mass in order to evaluate the relevance that a document will have. So in this case, we consider a lexicon, a vocabulary related to a given mental disorder, in order to measure how many words of this vocabulary each instance have. So those instances having more vocabulary or more words in this vocabulary, the mass of this instance will be greater. So if an instance only contains one word in the vocabulary, its mass will be 1. Instead, if we have an instance that contains maybe, I don't know, 50 words in the vocabulary, then the mass will be greater. So in this case, we evaluate two different lexical resources. In one way, we decide to use a knowledge-based approach in order to have this vocabulary, and the other approach was to use a database vocabulary. The first one was taken from a dictionary related to mental health problems, and the other one comes from the same data, like building a TF-IDF vocabulary. Then we take only a subset of these more relevant terms in order to develop our lexicon. So in the experimental settings, we take advantage of the corpora developed in the framework of ERISC. ERISC is a shared task aiming to promote the research on mental health disorders from a perspective that is important to make this decision as early as possible, because maybe if you are able to detect a given mental health disorder, as soon as you do this detection, you can help the people. So this is the aim of this task. So we take some corpora from this shared task that is related to depression, anorexia, and self-harm. This shared task had been done from, I think, 5 years ago, more or less. So we take 5 different the data from 5 different editions. Each of these collections are composed by post histories from users writing on Reddit, and this data is labeled as positive and negative. And it's interesting that these corpora, all of these 5 corpora that we used, are developed under a criterion that the authors state that they were in some point diagnosed with having a mental health disorder. In this case, for example, if a user wrote in her or his post, I have been diagnosed with depression, or I have depression, or something similar, or with anorexia or with self-harm, these instances are considered as positive in order to develop this data. So these are the 3 mental illnesses that we are working on: depression, anorexia, and self-harm. And this is just a very, very brief definition of what each of these mental health issues are. And in the corpora, here we have the distribution of the corpora we used. And as you can see, we have a small corpora because it's hard to develop this kind of data sets. So you can see that, as mentioned before, there is a data skew towards the negative class, or in this case, the control class, that are healthy users, against the positive. And it is interesting, I will to mention that in the case of our experiments, we only take the training data from each of these corpora. Then in the case of the depression, we are discarding all the control data for training purposes. Then for testing, we're considering all this data because we are interested in to evaluate how our method is identifying, in particular, these instances in each case. So in order to measuring the relevance or the mass for the users, we, as mentioned before, we used some lexicon, lexical resources that are related to each of these mental health issues. And here I put some workloads with the words that are in these lexical resources. And then you can see that, for example, in the depression lexical, we can identify some the names of some medical treatments or some feelings, or in the case of anorexia, we found some related words, some vocabulary that are very used by people in this having this mental issue. In terms of the text representations, for the case of depression and anorexia, we used a bag of words and word embeddings. And in the case of self-harm, we used word embeddings and also the BERT. That I will mention that these experiments were carried out into different papers. So this is the difference because we work on these topics and we present these results into different forums. Our results, we decide to compare our results against other one-class classification methods in the state of the art, and also we decide to compare our method against the best performing methods in the shard task. So here you can see the results. Our method outperforms those from the state of the art in one class classification. So it means that our approach is working well. And when we compare the results against the best performing approaches in the shard task, we only outperforms one of these results. Unfortunately, the other are not higher, our results, but they are still very competitive because we need to remember that in this case we are only using the positive instances, while in the shard task the participating teams are using the world data, and sometimes they are also using very powerful methods, more powerful methods, in order to address this task. So we did also an error analysis because of the nature of our approach. We can interpret easily our the way that we the way that our approach is performing. So we identify among the false positive that some users were labeled as positive instances because they tend to speak about the mental issue of other people, for example, a friend or a relative or whatever. So like our method is relying a lot on the lexical resources, these users are labeled as positive when they are not. And also, we identify that among the false positive, when we analyze the data from anorexia and depression in particular, we identify that these people that were identified that having these mental health issues are talking about other mental conditions like attention deficit, post-traumatic disorder, etc. So it means that in some way our approach is capturing these users that are speaking about a mental health disorder, even when these users are maybe not having these particular problems that we are focusing on, like depression and anorexia. And in the case of false negatives, again, as our approach relies in the content of the lexical resources, we identify that some users tend to write a lot about other topics like technological products, movies, etc. And only some few sentences are related to their mental health illnesses. So maybe a user just write, I had been diagnosed with depression, and then in the rest of the history of her or his post is just speaking about other topics. So these are very, very difficult users to capture with our approach. In the case of self-harm, we decide to make a different analysis. So we can, in this slide, you can see that if we observe in the true positives, the true positives instances are those having the greater mass values. So our approach is capturing these users correctly, while in the case of the negative, the true negative, if we consider the distance, we can see that the higher distances are present in the true negative. So in some way, our approach is working well. So just for finishing my presentation, in conclusion, we tackle the mental health detection in social media by using a one-class classification method based on the concept of the textual attrition force. Our method outperforms some baselines, and the obtained results are very competitive and encouraging against the state of the art. Our outcomes are easier to interpret than other in the state-of-the-art models, and as future work, we are interested in to evaluate our approach in data from other social media, because we are only working on Reddit data, and also we are interested in to consider early risk detection perspective, so trying to do with the least amount of information as possible. Here there are the two publications where we speak more in detail about this approach that we are following. And thank you very much. It's all. I don't know if you have any question.
Thank you very much, Delia. That was a great presentation. So let's see, there is a question in the chat. I'm not sure if it was originally posted for Hiram, but maybe you can answer it anyway since it was not answered previously. From Ricardo, this says, diffusion models that create photorealistic images from text prompts had been extended to create 3D shapes ready for virtual worlds.
Thanks, Delia. I think you don't have a question yet here in the chat.
I see. Okay, there is another question here.
What happens after a user is detected to be at risk?
Yes, I can read the question from Eric. Yes, you're right. Indeed, when we start to work with these approaches, I make a research at Google, and I think I put like something related to self-harm, and the answer of the first page that I read was a link, like providing some support, and you can also try to do. And unfortunately, we need to work a lot on this topic. This is not it's not easy, because maybe you can just use these platforms for looking for some information, or maybe just for sharing. And the idea will be in a future to identify if these users are having a mental health disorder, and then trying to provide them with resources, but not only a link, maybe also trying to contact with him or with her in order to speak, or maybe to help these people, to encourage them to look for the proper professional help, because maybe in these cases we only can do this providing this information, but also maybe we can try to figure out if these chatbots could help. Maybe if we identify that someone is having this problem, maybe a chatbot could contact them and then try to help in order to express the problem, and to avoid to have or to have this unfortunate situation that leads to suicide. You are right. Sometimes these kind of mental issues have this are previous to having this kind of situation related to suicide. What other prevention methods are available? I think that, as mentioned, we can only we can see that sometimes only a link is provided. So this is not enough, of course. We need to continue working on this, because if we are developing automatic tools, the idea will be to provide real help, or more useful help for these people. I have another question that is yes, not of course. The question is that how are the idea of the professionals in health of using IA in order to help, because I think that is very important that when we speak with professionals of health, to present these words like a tool, not like a way to replace them, because it is not true. We cannot replace the professionals, but we can help them. So I have a chance to work with some medical professionals, not yet in the psychologist or psychiatric domain, but with a different domain in the health situations. And some of them are very interested in to be part of the development of this kind of methods, but of course there are others that are like not so convinced that this can help. So this is a work that we need to do, the people working on IA, not only in the natural processing task, but in other areas, that we need to identify the ways that we can work with each other, because I'm sure that we can help a lot if we work together, that we are not in different problems, because they are addressing these problems from their perspective and we are addressing these problems for our perspective. So I think the best idea is to try to share our ideas and try to develop some things all together. Thank you for the link. I will read it, Vinicius. Thank you.
It was so interesting, your presentation. Thanks, Delia.
Thanks again, Delia. Thanks, Tania. So, thank you, everyone. Estevam. Yeah, okay. So, before you started, I hope everyone is safe and well. I apologize again for the technical problem and the delay for the presentation, guys. So, it's a pleasure to be here with you, and even a great pleasure to introduce Estevam. Estevam was my professor, actually my best professor during my master and my PhD and the Federal University of São Carlos in Brazil. So I'm very happy to be here. So thank you again, Estevam. If I will read all the Estevam curriculum, I will be probably use all the time here in the event, but I think it's important to do some highlights. So Estevam was an associate professor at the Federal University of São Carlos, and he also was an adjunct professor at Carnegie Mellon University. So together, Professor Tom Mitchell, Estevam created the NEL. It's a never-ending learning paradigm. And he worked at Amazon in conversational AI projects. And he has over 6,000 citations for his publication. And he is currently lab director and staff research scientist at Megagon Labs. So thanks again for your kindness to accepting the invitation to be here, Estevam. Thank you very much. And please feel free to start your presentation.
Thank you so very much, Vinicius, for the very kind introduction. Thank you also for all the LatinX organization here for the invite. It's a pleasure and great honor to be here with all of you. So because I'm not seeing the gather town screen, Vinicius, because I'm looking this presentation mode, if you or any have any questions, please interrupt me by voice, okay? Because I will not be seeing what's going on there. So,
okay,
thank you so very much. Today we're gonna be talking about matching entities from structured and unstructured text. And I will try to give, actually, in this talk, a very brief overview on how we can go a little bit beyond data-driven AI, or natural language processing, towards more what I am calling here a data and knowledge-intensive AI, natural language processing. So as Vinicius said, I am Estevam Hruschka. I am with Megagon Labs. Just to give you a very quick idea of that, so Megagon Labs is the research arm of the Recruit company. Recruit company is our parent company that owns many other companies around the world, including, for instance, Indeed.com, Glassdoor, and so on. And what we at Megagon Labs do is the research work that needs to be done in the areas that are important for the company. So usually the other big companies also have the applied science teams there, and Megagon Labs is more a research-focused one. Okay, working on this kind of things, working at Megagon Labs, we are usually focused on this kind of activities, and today I'm selecting one of the biggest focus that we have, which is having unstructured, semi-structured, and structured data. How do you do different types of matching? So we are talking here about, like, imagine we have a resume given from a user, and we have a job description provided by a company. How can you actually go and check whether there is a match here between those two? Or can I really rank the best resumes for the best job description, or vice versa? What is the best job for someone, and so on? That can also happen in different applications. So we can try to match students to the content of the courses that they are going through. We can try to match news and whether they are aligned to what the user wants to see or not, whether they are fake news or they are trustful, and so on and so forth. We can match, for instance, products to what people are saying. So based on customer reviews, what are the products they are talking about, and many, many other applications. So this is a very important and relevant task to be solved, and it usually involves a lot of natural language processing. Yeah, and in some cases, there are situations in which the data that is using for this type of matching can be in tables or more structured way. Yeah, so in those scenarios, I'm calling it here like the structured data only scenario, in which you have tables that can be web tables, can be database tables, or so on. In this scenario, we at our lab at Megagon Labs, we have work that are targeting this type of things like Sudowoodo, Dudu, Machop, Mino, other Pokemon names too. But I'm not going to focus much on this. I'm just putting here some reference if you are interested. And what I would like to talk today is in a different type of granularity of entity matching. Yeah, so let's imagine a problem that's a little bit more general, in which I don't have a table, I don't have a specific a field or attribute in a relational database that I want to match with another one. No, I have more complex things. So for instance, I might have a job posting here in which it uses lots of natural language and free text. I have a resume here that also uses the same type of things. And I'm not even talking about necessarily matching one entity in the sentence to another. So for instance, I'm not necessarily trying to match the city that is mentioned in a sentence to the city that is mentioned in another one, or things like that. I'm trying to match, let's imagine, the two high-level entities. Yeah, so the entity of the job posting itself and the entity of the resume itself. So considering these kind of things, we are talking here about a very challenging task. And currently, like state-of-the-art models, what I'm calling here SOTA, so state-of-the-art natural language processing models, can really be used and are used for this type of tasks, but mainly because they are just data-driven and they cannot really incorporate the knowledge about the specific setting of the task we want to solve. Usually they don't do really good in all the situations. And there are cases here in which they will fail, and so on and so forth. So what I would like to be talking from now and on in this talk is just a little bit about, okay, one team that we have in Megagon Labs that we call the Knowledge Hub team, that we are trying to say, okay, what can we do to improve current state-of-the-art models, mainly when we're talking about natural language processing? What can we do to improve current large pre-trained language models to help us in the task? And the way we want to do that is injecting specific knowledge towards those models. This knowledge injection can happen in many different ways. So let me try to show you a little bit, 2 examples here on how we are injecting knowledge for this type of large pre-trained language models to help us solving natural language processing tasks. Okay, the first one I will just get one recent paper we got and findings at NACO this year in July in Seattle. We presented this, which is talking about low resource entity set expansion. And we did a comprehensive study on user-generated text. You see that this is somehow related to the problem that we just saw Delia talking about a few minutes ago, in which we have a task that we don't have negative examples, but we have a few examples of positive class, and we would like to extend the instances or examples of those positive cases that we know. That's what we call entity set expansion. We are also adding some extra constraints here in our definition of the problem, and the main one is we are focusing on what we call low resource setting. So we are telling, okay, let's imagine a scenario in which I want to find new instances of concepts, and I only know 10 or less than 10 positive examples for those, and that's what I know. I don't know anything else. So how can we keep going for that? We can have this expressed here in example that let's imagine you have a corpus with hotels, hotel reviews, and you have a small seed of entity sets. For instance, we have a few examples of names of hotels. We might have a few examples of names of location, attraction, so on. And we want actually to extract or extend this set. So that's what we are targeting in this problem setting here. Okay, given this, if you go to the literature, you're going to find that there are some entity set expansion, I'm calling ESE here, methods that can be considered state-of-the-art. But usually those methods are proposed for extraction of information from what I'm calling here well-curated data, not user-generated data. So UGT, user-generated data, are different from well-curated data, which is again similar to what Delia was talking in her presentation. When someone goes and writes a review or someone writes something on the social media, that type of text is not well curated, and it adds lots of difficulties for natural language processing traditional tasks or approaches to solve the problem. Okay, so then when you look at that and you look at the characteristics that we have in user-generated text, you're gonna find that usually they have these properties like of being a little bit more fuzzy. So they have lots of what we call multifaceted entities. It means like you have lots of entities or examples for a concept that can be actually used for more than one concept, not a single one. We also have vague entities, which means that if you ask a few people to tell you whether civic center, for instance, is it an attraction, a touristic attraction or not, some people might say yes, some people might say no. So it's not a fact that this thing is an attraction. This is a little bit more vague and depends on the intuition of the user to say yes or no. We also know that we are talking here about things that are not really the classic named entities. I mean, usually you have proper names like companies, organizations, locations, people. Those are classic named entities for which entity set expansion techniques work well. But whenever now you're talking about a different kind of concept, so let's say, what do you find in a room of a hotel? So room features of the hotel. Oh, you can find coffee, you can find TV unit. You see, this is not a named entity thing. So then the state-of-the-art models usually will fail doing that, and so on and so forth. Okay, so we first identified these properties, and look at that. That's what I want to call attention here. When trying to solve the model or the problem, instead of just getting the model and getting a large pre-trained language model and trying to apply it and fine-tune it to your task, it's very important that you come back to your task and try to understand, okay, why is this task different from previous ones? Or if not, okay, then I just take the state of the art, use it, I probably will have a reasonable result. But if I understand that the task I am talking about here is different somehow from what is the traditional setting in which the state-of-the-art models are being used, I must pay lots of attention to that and try to add some of those concepts or some of those type of knowledge about the specific characteristics of the problem so that your model can do better. Yeah. So we started doing this. We identified these properties for whenever the user-generated text is available. And then we start some experimental setup to understand how much we can just use state-of-the-art or should we do something else. And then to try to use actually state-of-the-art models. We got two exemplars coming from two different approaches. One, a more corpus-based approach, set expand. Another one, language model-based approach, CG expand. We have the references for them. So those are not our papers. We are trying to get actually what the literature shows us. And then we also create some combinations of this. We try to say, okay, how can we have different ideas that can combine corpus and language model-based approaches here. We then propose some of those combinations. I'll show you in a minute, but that's what we worked in our experimental setting. We also use as benchmark different data sets here. We got some well-curated text benchmarks. So we got Wiki, which is a traditional one that considers like 8 different concepts that we want to expand. And we also generated 3 and made available 3 data sets that are more user-generated one. One coming from Yelp, talking about restaurants and reviews and so on. Another one, TripAdvisor, also talking about touristic attractions and so on. And one using our internal data from jobs, in which we are talking about company, dress code, job position, and so on. So based on this, we also identified what is the traditional metric that people use when trying to solve this. And we realized that usually in the literature, people fix their metric and trying to understand what are the performance of the methods when you fix K and you say precision at K, let's say precision at 10, at 20, and so on. So in this case, you are not interested in seeing how much you can really extract or extend this set, but you are just asking the question, oh, can I find 10 good examples of cities or 10 good examples of hotels and so on and so forth? We actually see that this is not the real case scenario in an application where you want to extend your set, definitely. So we propose to use what we call the golden K. Yeah, we try to have the estimation of how many examples would be there, and we evaluate the performance of the proposed approach based on that big set, not only at the top of it. So this is the setting. I'll try now to just show you our findings when trying to examine this type of problem in the user-generated text setting, okay? So what we found is first, the properties that we were talking about, so multifaceted, non-name identity, and vagueness is really much more present in these green data sets here, which are the user-generated ones, and much less frequent in what we call the well-curated data sets. So it means not necessarily the state-of-the-art that we see in the literature that works so well for the well-curated ones will be the ones we want to use in our domain. So second thing that we found here is that talking about the metric that we are using to evaluate this performance, literature is usually fixing, as I told you, precision at K. So they try to see here, okay, how precise is my method if I set K to 20? So it means how precise is my method if I want to extract 20 examples for that concept that I'm trying to extend. And you see here that the orange line here is a state-of-the-art model, CG expand, a good one, and that really beats other approaches when you fix K to 20. But if you're talking about amenities, and here we were talking about specific things in a hotel and things like that, you see that the estimated golden K is kind of 200. And if you look a little bit after K, so whenever our K tends, for instance, to 50 or 100, actually a language model, a baseline based on a language model can do much better than actually the current state of the art that literature reports. So if you are interested in only 20 extractions, please go for the state of the art. If you're not interested in the first 20 examples only, please pay attention to this, that maybe your model might need to be different from what are the current state of the art. So we did that, and we have this happening in different situations again, and in the paper you can have more of this. I will not go over all of them just for the sake of the time. Also, some interesting findings here with the experiments. So if you look here, blue and orange, the two first one are the state-of-the-art methods, yeah? And then green and red are actually baselines that we proposed. And then purple and brown actually met a model that we proposed to combine different approaches using MRR technique that is proposed in the paper. And you see that those two are the last ones. What we would like to call attention is that in the curated data sets like Wiki and APR, you see that the state-of-the-art have good performance. In this one, like similar to the ones we are proposing. In this one, even better than the ones we are proposing. So they can achieve very good results. On the other hand, for the domain that we are more interested in our specific case, which is the user-generated text, we are seeing that the state-of-the-art models really are below in the performance here, yeah? And the proposed methods that we are working on are doing much better. Okay, given that, the key takeaway from that is pay attention to the problem. Frame your model accordingly to the main characteristics of the domain and the task you want to solve, okay? Another type of, and this is a type of knowledge that you should inject in your proposed systems or approaches. Another type of knowledge that you can inject in your models and things like that can come from humans that might be in the loop. This is a paper that I want to call attention here that is actually a findings paper for this EMNLP. So you might not find it in the presentation, but you find the video in EMNLP webpage, and you can pass by Megagon Labs booth 2, and our team will explain more. But let me give you a very highlight or high-level idea of this. What we are talking here is like you can also have people helping labeling some data. So what should you do if you have a user that can label a few examples to help you fine-tune language models in this few-shot learning approach? Usually, if you just randomly select instances to be labeled, you might not be optimizing the signals that you might want to do. So we here propose Tyrogue, yet another Pokemon, you see, which is a novel acquisition function that can help you to identify what are the examples that you should be focusing on if you want to label a few only to go for a few-shot learning, fine-tuning your large language model. We got empirical evidence with Tyrogue that it can really reduce the acquisition latency and labeling cost when you compare, again, to against other state-of-the-art models. I will not go much into the details just because of the sake of time, yeah? But what I would like to say is that what we do in our proposal is we actually put together the more uncertainty-based active learning ideas that literature reveals to us, together with the diversity ideas of active learning approaches that we also know from the literature. And when we do that, we can actually put a pipeline in which we do one initial random filtering because we are also interested in having low latency. So we want actually a model that you can add new examples, run it very fast, see the results, and see, do I need more or not? So that's what we are trying to get here. With this approach, we did some experiments and we identified that we can reduce labeling cost. It means with less examples, you can achieve the same performance that you would have from supervised models. So here, We are targeting less than 1,000 new labeled examples. And you see that if you want to target a percentage of 0.85 of what the full supervised version would reach, you see that using the very first column here, which is TIROG, and the other ones are actually state-of-the-art models in active learning literature, TIROG really can reduce the number of examples you need to get to this performance. And whenever you are now targeting getting 0.95 of what you can do with the fully supervised version, you see that TIROG can even get an even bigger difference here from what the other models can give you. As I said, we have the paper in findings here at EMNLP. I can also answer more questions, but I will try to just say what we did in those two works that I brought today to discuss with you is like, how can you get specific knowledge about the tasks and problems you want to solve, and then specifically use that knowledge to inject properties, constraints, and assumptions in your modeling so that your model now can be more cost efficient and more adapted to the task you want to solve. This is actually the conclusions from this talk. Matching entities from structured and unstructured text is challenging, very important in many domains and applications. Large pre-trained language models can be very helpful for us, but are not ready to provide optimal solutions all the time in all scenarios. Then working on ways to incorporate external knowledge in the models can bring great improvement. Sorry about that. Here I showed you a few examples of that. I showed how you can add properties about the problem to your models and improve performance, how you can think about new different evaluation metrics, and how you can include human feedback to the process. Thank you so very much. It is really great to be here. I think we might have time for questions, but just before going for the questions, let me also let you know that here during this EMNLP 2022, our lab has this paper in the main conference that will be presented Sunday. So please come to see it if you're interested in summarizing community-based question-answer pairs. We also have the paper I mentioned a little bit about to you in the findings that you can find more in our booth, low resource interactive active learning for fine-tuning language models. And we also have today earlier a work in the DASH workshop that happened about exploratory labeling for natural language processing computational notebooks. Thank you so very much once again. And yes, please, Vinicius, let me know if we have questions.
Okay. Thank you very much, Estevam, for the brilliant presentation. Thank you again for accepting the invitation. Actually, you don't have yet any question in the chat, but if possible, I would ask you talk a little bit this difference about because your background is academic, you are a brilliant research, but nowadays you are working in a solution and to solve real problems. So in your presentations, you can see some difference for the results for the research problems and real world problems. In your opinion, what's the big difference in these two words, if I can see this in this view?
Thank you very much for the question. And I will stop. I'm not sure whether it stopped, but I think I'm not sharing anymore. Am I? No. Yeah?
Yeah.
Good.
You are sharing your screen.
I'm still sharing. Let me just stop that then.
Yeah.
Because we can talk like this. Thank you.
Okay.
So thank you for the question. And this is a very interesting topic. Yeah. So as you know, I'm really passionate about research. And I spent 20 years in academia working as a professor and so on and so forth. And then I tried a little bit industry in 2017. So to me, the main difference between academic research and industry research is the following. Speed and impact plays a lot of role, or a very important role here. So in academic environment, you have much more flexibility and you are really allowed to go in the pace of the research to try to figure out mid and long-term projects and impacts that you want to get. When you go to industry, usually you will have a scenario in which for most of the positions you will find, you need to go towards near-term results and not really so much mid and long-term. Few places will allow you to go kind of in between. And to be very honest, what I did when I moved to Megagon Labs was trying to figure out or find a place where I can have this in between. Yeah, so there are places, Megagon is not the only one, but there are places in industry that you can be not like so far from what you would do in academic world, and not so far from the impact and the speed that you can have if you are in the industry scenario. So I think it is very important for someone to see what they really like. And once they decided this, if impact to real case scenarios and speed in doing things is important, usually the industrial setting would be better, I would say. If you want to have more time to plan in long-term impact for your career, usually the academic scenario is better for you. Yeah, but there are some places where you can be in between. So that's what I would say. There are not many places like that, but there are a few places that we can do this kind of thing. Yes, I can go deeper a little bit. Let me know if I didn't answer your question.
Yes. Thank you very much. I'd like to ask you, Estevam, about once you have in the NLP conference and here in this specific workshop, the social Latinx, when Latinx working with Latin people, Latin American people, we see a lot of research, benchmarks, data sets in English. So it's very few data sets in Portuguese, for example, from Brazilian or Spanish. So in your opinion, when you talk about the multi-language models, you can surprise this problem with data sets in other languages, or you can do more for the other language like Portuguese or Spanish?
So that's a great question, Vinicius, and I would put it in perspective to the way we were having this talk that I brought today. So I think that we are having tremendous advancement in large pre-trained language models nowadays, as all of us know, yeah. But they are mostly focused on the main resources that we have available on the web. And because we have lots more resources in English, so this becomes much stronger in English language, yeah. So there are nowadays with transfer learning, a lot we can do from transferring the learning of language itself towards other languages, yeah. But it's really only on the high level and general averaging scenario. Yeah, so for the specific things that we have for each one of the languages that we might be interested in working with, usually the transfer will not be perfect. I'll bring here a very specific or a very close example. I talked in the talk here about user-generated text and well-curated text. Yeah, so you see that even in the same language, English, whenever you get a text that is well-curated, and your models are built for those, when you apply to a different type of text or language, which is the non-well-curated, you have problems, like the performance is not the same. I would say that now if you go for a different language, from English to Portuguese or Spanish and things like that, that will happen, and maybe even more than just from well-curated to non-well-curated one. So to me, what is very important is that we take advantage of the average knowledge from language that the English can bring, models can bring to us, but I still see the need of focusing, targeting research on how we can inject specific knowledge for those specific languages into a way to better model them. So in other words, I would say that transferring from English to others can give you a reasonable baseline on average, yeah. But if you want to really go to very good results, I think it's really important that we focus on what is the specific knowledge of that language and build a specific model based on that language. Like it can even be on top of what GPT tells us. Yes, and that is actually a good idea. But I still see room for us to add specificities towards the language we are targeting.
Great, thank you. And for the last question from Alex, he asked, how much importance would you place in the human in the loop in order to help improve our NLP projects?
That's again an excellent question. So I will give you an example on that based on this very recent thing that we have, Chat GPT. Yeah, everybody's talking about Chat GPT for a good reason, because it's really impressive. But let's put into very high level perspective here. It's not the only one, but one of the great difference from GPT-3, GPT 3.5, and so on and so forth, to Chat GPT is the dialogue idea. Yeah, so in the dialogue version of it now, you can have a human or another agent, interacting with GPT and trying to guide towards what is the result or answer that you are really looking for. So I think this is a very interesting signal telling us how much the human in the loop is important. You see that this huge achievement came a lot because now you, human, can interact, can get the next turn. It's not a single turn conversation anymore. You can actually add new details. You can actually add new constraints and get the results closer to what you would be expecting. So this is an example to say, to me, human in the loop is more and more important, but maybe a little bit of change in the focus, in which a lot of work has been done in the past for natural language processing, having humans in the loop, for instance, to doing annotations. Yeah, I even gave an example here of trying to find instances to be annotated. In that case, the human is in the loop trying to help the models, which is great, and we have been doing very good amount of research on that. I see that now a need on changing focus that has started already is also not excluding this first row of the human in the loop, but adding the other rows that the human might be. And in that sense, we should also have the human in the loop, but now with the models and the approaches and systems actually trying to use the human as a guidance to where they should go and what is actually the need that the human has, so that the model can learn more about that and learn to get closer and closer to what the human needs, not necessarily just using the human to label some data to improve the model. But this is a fascinating area, and I think lots of room here for doing very good research.
Great. I agree with you. It's a very fascinating area, and you can talk about it all the day. But,
I agree.
Yeah. Thank you, Estevam. Again, thank you very much. It's a pleasure to be here.
Vinicius.